We did 1 and 2 last time, and just reminder, if they ask you to select multiple item or multiple people in this case, then if it's multiple people, remember we need to multiply. If they ask you to select one person, then you have to ask yourself, is that item mutually exclusive or not mutually exclusive, right? So in this sense, we went over number 1 and number 2. Find the property. If you select 2 people at random, find the property of select a male and then go back and select a female without replacement. And I mentioned to you guys that without replacement, meaning you select one item and then that item is outside, you go back and select another one. Or in this case, you select one person and that person go outside, stay outside the room, and you go back to your room and select another person. So the first time we went in, we know that there are 11 male out of 30. So the probability of select a male is 11 out of 30, and I got that male student. I tell you that male student to go outside the classroom, and now I go a second time and reminded the second time we no longer have 30 because one of them is on the outside. We only have 29 left, right? So in this case, why is 19? Because there are 19 female, but out of only 29 students because one of them have already taken out. And once we have this, all we need to do is 11 times 19 and 30 times 29 to give you 0.240. And vice versa for number 2, we want to select a male and then we go back and select a person who in the age group of 30 to 35, which replacement, meaning we select, we record them, and then we go back, we tell them, bring them back, and we record or select again. So in this case, the probability of a male, the first time I go in is 11 out of 30. And then I wrote the name down, I tell him to go back. And then I select the second person, and the second person, there are 7 of them in the age group of 30 to 35, over 30 people, meaning I still have the group of 30 people as the same as before. So once I have this item here, all we need to do is multiply and divide. And like I mentioned, the difference between replacement and without replacement is the denominator is the same if you replace them back. And if you replace them back, meaning the first probability do not alter, do not affect the second probability. Therefore, the 2 items are independent. This thing here, the probability change it. The first probability affect the second probability. And because they affect the second probability, they are dependent on one another, okay? So this is the 2 problems we did on Thursday. Let's take a look at number 3. Number 3, they ask you find the property of select both female with replacement. And again, same idea. We go in the first time, we want to select a female. We record her name down and we tell her to go back to her seat and we select another female. And again, and then, right? Select the first one and then select a second one. Because we need both of them, we need to record both of them. So in this case, the probability of the first female is 19 out of 30. I have 19 students out of 30 students. And I wrote her name down. I tell her go back and I select a second item, which is the second people, which is we have the same 19 out of 30 because I still have 19 female out of a group of 30 people. Looking at this thing here, all we have is multiply the top times the top and the bottom times the bottom. So in the sense, the different, some of you might ask me or may say, well, what is it possible if the 2 people you select is the same person? Yes, it's possible, right? Because the first person, when you return, you write her name down, that person still have the same probability as the first time. right? And that's why, yes, in this case, we basically want to select them, and the two people that we select might be the same because we replace them, because each time we select them is the same, right? And question in terms of number 3, or in terms of why my denominator is the same, or why do I have the same probability? And again, the difference between why I have the same exact probability is because the criteria is the same for both of them right here, right? I'm select a female and another female, or and then a female. This one here, the criteria is a male and then an age group of 30 to 35. So because they have different age group or different criteria, that's why the numerator are different. Okay. Similarly, for number 4, they ask you to select two people, and the first person is in the age group of 42 to 47, and the second person will be in the same age group of 42 to 47, but this time we don't want to replace them. We want to make sure that we have two different people, right? And that's what the replacement and without replacement do. Because without replacement, meaning you took that person gone. We go back and select a second person. And this, we guarantee that we have two different people, right? Because the first person, once you choose them, they don't have the chance of get choose again. So if I go in the first time, I have only 3 in the age group of 42 to 47 out of 30. And I know it's very small, it's only 10%, right? 3 over 30 is only 10%, but we assume that we got that person. So we got that person gone, we go back the second time. In this case, the second time, we no longer have 3 people in that age group, but we only have 2, and we no longer have the total of 30 because one of them is already taken out. So in this case, we have 2 over 29, 3 times 2 is 6, 30 times 29 will give you 870. And if you divide them, you get 0.007. So the idea is identical, the idea is the same. The only question is you ask yourself is, do we have the same same denominator if we replace them? Or if we don't have the same common denominator because we do not replace them, okay? So question here in terms of this particular item. Any question? So one thing I want to point out that you might not see it during this time a lot, but this is what we have is this probability right here, 0.007, we will say, or we call this a unusual event. The probability of this item is unusual event, and the reason why it's unusual event is the cutoff. If your probability is less than 0.05, meaning less than 5%, we say it's unusual. It's hard to occur. So the cutoff for unusual versus usual is the 0.05 or 5%. Okay. So if you look at this right here, 0.24, 0.08, 0.4, those are usual event. Those are just a usual event, meaning is have more chance of occurring, is usual. The unusual event is when it's less than 0.05. Everybody see that this thing here is only 0.7%. It's not even 1%, it's only 0.7 of the percent, right? So the cutoff is 5%. Anything less than 5%, we say is unusual. And we will deal with that unusual item a lot more in chapter 5. I'm not sure if they ask you in chapter 4, but if they do, just know that if it's less than 0.05, any probability that less than 0.05, we call them unusual, okay? It still can come out. I mean, the chance of come out is still there. It's just that it's unusual to come out, okay? So let's take a look at this particular problem. What if, right? What if they don't give you What if they don't give you the raw data and they just give you the problem itself? So in this case, for this particular problem, they give you these two probability. They give you the probability of Laura and Philip. Each of them fire one shot at the target. Laura have the probability of 0.5 of hitting target, meaning again, she shoot it, and the probability of she hit the target will be 0.5, 50%, 50-50, right? And Philip have the probability of 0.3 of hitting target, meaning again, 30% or 30% that Philip will hit, 70% he will miss. The shot are independent because Laura is different from Philip. So each of them, if they stand side by side and they shoot, each of them do not affect each other, right? So looking at this item here, part A, they ask you find the probability that both of them hit the target, right? So basically they ask you find the probability of Laura hit the target and Philip hit the target. So we know, right? And this is the challenge, you guys. This is the biggest challenge for you guys, like I mentioned, is how can you take this wording and then extract out your information, right? So we know that they give us that Laura, the probability of Laura hit the target is 0.5 or 0.5, right? And we know that the probability of Philip hit the target is 0.3. So those are the probability of the individual, Laura and Philip, right? And now they ask you, what is the probability of both of them hit the target? Meaning the probability of Laura hit the target and the probability of Philip hit the target. And because of, remember, they are independent because each of them have their own probability. All we need to do is take the probability of Laura hit the target, multiply to the probability of Philip hit the target. The 0.5 is the probability of Laura hit the target, and the 0.3 is the probability of Philip hit the target. That's why we have 0.15 that both of them hit the target, right? Philip hit the target, and also, Laura hit the target. So question with part A here. Part A kind of easy to see because they are independent. All we need to do is take the two probability and multiply to each other. Now, part B is a little bit, if you read this thing here, you have to really decipher what you read. So part B, they say, given that Laura hit the target, what does it mean? Given Laura hit the target is a conditional probability, right? And remember, the conditional probability is anything follow the word given. So first of all, the condition is Laura have to hit the target. That's the condition. Given that Laura hit the target, the probability is 0.5 that Philip shot hit the target closer to the bullseye than Laura. So everybody see the picture here. Laura shoot first, she hit the target. Philip shoot second, and he hit the target and closer to the bullseye than Laura is 0.1, which is 10%. But there is a conditional probability is first, Laura got to hit her target, meaning again, Laura hit the target, doesn't matter where, Philip shoot it, and his bullet hit the bullseye, not the bullseye, closer to the bullseye than Laura is 10% or 0.1. So that's what we have, which is a conditional probability given that Laura hit the target, Philip hit closer to the bullseye is 0.1. Now they ask you, the question they ask you is find the probability of Laura hit the target and that Philip shot is closer to the bullseye than Laura shot. So look at this item. We know that this is the and the only reason why they given you in this description is they hopefully you can connect the and probability, right? The probability of this and that, in the sense that we find the first probability multiplied to the conditional probability. Given that Laura hit the target, the probability that Philip hit his target closer to the bullseye than Laura is 0.1. Okay. And in the sense, if you look at this item, this is what they ask you, right? If you write this into symbolic A and B, or if you write this thing here, we find the probability of Laura hit the target and Philip hit the closer to the bullseye than Laura. So what is the probability of Laura hit the target? Well, the probability of Laura hit the target is 0.5. That is the same probability from our previous or from our information, right? 0.5 is the probability of Laura hit the target. And now, what is the probability of Philip hit closer to the bullseye than Laura shot? And that is the probability we have, which is 0.1, because they give us that probability. Given that Laura hit the target, so Laura hit the target, the probability is 0.1 that Philip's shot is closer to the bullseye than Laura. And in the same, or in short, this is all they ask you to do is multiply the two probabilities together. Because they are independent, all you do is you take the two items and you multiply them. Okay. The only thing different, or the hardest, the challenge for you guys is how can you decipher the wording. If you look at the math, this is the math, right? The multiplication, very doable, very easy. Your calculator can help you out, right? The multiplication, that's the math. How can you take all of this wording and convert to the math that you know how to do? And that is your objective. Before we move on, let me ask you, or ask any of you guys have question with this particular problem here. All right, let's take a look at the at least one. And some of you guys sent me a question over the weekend related to the next problem. I was not able to reply because I have it on this slide, and I plan to go over it today, so that's why I did not able to reply your email. But let's take a look at this particular problem. And if you look at this problem, and that's the challenge for you guys, is when you read this problem, what keyword or what trigger the item that we're looking for, right? If you glance through, if you scan through this problem, you see that they ask you, what is the probability that at least one of them require replacement in the first 6 months? So you see, or if you remember, we need to find the at least one. And if you remember the at least one formula, the at least one formula was the probability of at least one is equal to 1 minus the probability of none, right? If you remember from last Thursday, to find the probability of at least one, we need to take 1 minus the probability of none. Okay, so that's the trigger word, right? Those are the key words that you're looking for. Now let's go back to the information they give us. What information is there that we can use? So they tell you the probability that a certain make of car will need repair in the first 6 months is 0.3. The dealer sell 4 such car. What is the probability that at least one of them require repair in the first 6 months? So we know that in order to answer this question, we need to have the probability of none. How many cars does or did the seller or the dealer sold? Well, they sell 4 cars. And looking at this item, first of all, do you agree that the probability of each individual car, for each individual car in this dealership, for this individual car, for this particular model, for each individual car, the repair they need to bring back to the dealership to get repair within the first 6 months is 0.3%, not percent, sorry, 0.3 probability is 0.3 or 30%, right? So for each individual car is 30% that they have to bring back within the first 6 months to get some kind of repair. We don't know. It can be tire, can be oil change, whatever, right? Now, if the probability of repair is 0.3, do you agree that for any particular individual model of this model call, the probability that does not need to go back to get a repair is 0.7, right? So same thing as the probability of rain is 0.3, then the probability of not going to rain will be 0.7. So if the probability of repair is 0.3, then the probability that does not need to go back for repair in the first 6 months is 0.7. But reminder, the thing that you need to remind yourself is whatever you just find here is just for one particular call or one individual call. Now you have to do for 4 of them, right? So for 4 of them, for one call is 0.7, but for 4 of them, what do we need to do? Well, for 4 call that does not need to go back and get a repair in the first 6 months is 0.7 times 0.7 times 0.7 times 0.7. Meaning again, the first call does not need to have a repair is 0.7. The second call that does not need to have repair is 0.7. The third 0.7 and the fourth is 0.7 because each call are independent from each other, right? The first call go back repair doesn't tell the second call, hey, I go back, you go back too, right? So each call have their own independent item. And why do I multiply? Because it's the first call and the second call and the third call and the fourth call. So in order for me that none of the 4 call that I sold, none of the 4 call that this dealership sell need to go back for repair in the first 6 months is 0.2401. 0.7 times 0.7 times 0.7 times 0.74 times to give you 0.2401. Now, that is the probability of none. We are not looking for probability of none. Probability of none of the 4 call need to go back repair. We're looking for probability of at least one of them. And like I remember, not like I mentioned on Thursday, the worst case scenario, but in this case, the best case scenario for the dealership is none of the call come back to get repair, right? So how do I find at least one of them? Well, if I exclude the best scenario in this case that none of them come back, it will give me the remaining, the complement of that, which is at least one of them come back. It can be 1, it can be 2, can be 3, or it can be all 4 of them come back to get repair in the first 6 months. So how do I find the complement? Which is I take 1 minus none of the 4. Not the one, none, not the individual, but none of the 4. So 1 minus 0.240 will give me 0.7599. So roughly 76% that at least one of the call come back to get a repair. Again, one of them can be 2, can be 1, can be 2, can be 3, can be 4, because we exclude none of them come back already. We thought that none of them come back. Okay, so question here in terms of how to identify which problem we have, which is in this case easy to identify because it's at least one. You see the word at least one, and that is your at least one problem. So question on this particular problem here. Question on how I find the 0.7 or the 0.2401 or my answer 0.7599. All right. If you don't have, and if you did homework, you probably run into this particular problem. This is your homework problem. I just took it down because a lot of students sent me an email in my previous semester, so might as well just go over this problem. And again, your homework problem, the percentage might change, might be different, and that's it, right? So let's take a look at what we have, and if you glance through, you can see that at least one, right? At least one. That's what we have. But let's take a look at the information. Let's take a look at the data they give us, or the background story. The technology consultant Combinate Data Genetic suggests that 15.8% of all 4-digit personal identification number, or PIN code, have a repeated digit format such as 2525. Assume that this is true. If the PIN code of 7 people are selected at random, what is the probability that at least one of them will have a repeated digit, right? So you read that, you probably read again and read again. So what do we have? Well, first of all, similar to the previous call, do you agree that we have 7 people that we need to extract out? We have 7 people, 7 individuals that we do, just like the Thursday problem, Joe buy 7 tickets, right? Each ticket a day. In this over here, they sell 4 items. So first you have to know how many people we have, or how many items is there that we need to perform, right? We need to extract how many items out, or in terms of what is the total item we have from the at least item. And now the other number we have is the percentage, which is 15.8%. Hopefully you guys see that this number is useless. The 2525 is just tell you what the type of password or the PIN number that they have, right? So your PIN can be 1717 or 3939, right? As long as they repeat it in that format, then it's considered to be a repeated item. So what do we have here? Do you agree that for an individual person, based on this information, based on this data, for an individual person, the probability of he or she have a repeated PIN is 0.17158, right? 15% you have to convert that to probability, or in the sense you have to convert to decimal. So the probability of repeated PIN will be 0.158 for each individual person, meaning based on this information, if I choose one of you guys, the probability of one of you guys have a repeated PIN is 0.158 or 15.8%. And if we know that the probability of having a repeated PIN is 0.158, what is the probability that does not have a repeated PIN? What the probability if I pick one person and that person PIN is 1, 2, 3, 4, right? That is not repeated, right? But again, as long as it's not repeated in terms of the double digit, right? 1616 or 2020, right? As long as it's not in that repeated digit, the probability of not having those repeated, do you agree, is 1 minus 0.158 to give me 0.842. So each individual, the probability for one individual person that do not have a repeated PIN is 0.842. And similar to the call on the left side, that is just for the individual. Now we have to convert from one individual to 7 of them, right? So the first person, the probability of that person does not have a repeated PIN will be 0.842. The second person, 0.842. The third, 0.842. Same thing, same thing in terms of 7 of them. So this, if I multiply them, I see that 0.742 raised to the 7th power will give me 0.30007 right? Meaning none of the 7. I select 7 of you guys. Let's say that I select 7 of you guys, and none of the 7 of you guys have a repeated 2-number PIN. Okay, so that's what the process is. We take one individual and now we do it, compound them together in terms of how many people we need. For this one here, we need 7 of you, or 7 people. So the probability of none of the 7 that I have a repeated PIN is 0.300. And once we have the probability of none, to find the at least is the complement of none, right? At least 1, meaning again, either be 1, or 2, or 3, or 4, or 5, or 6, or all 7 of you guys, right? The probability of at least one of you guys, doesn't have to be all, at least one, meaning 1 or 2 or 3, so on, is 1 minus 0.3. So there is a 0.7 or 70%, right? There are 70%. If I have a group of 7 of you guys, if I have a group of 7 of you guys, any 7 of you guys, there are 70% chance or the probability of at least one of you guys have a repeated pin is 70% or 0.7. Okay, so that's the idea here is we want to know at least it can be 2, can be 1, can be 2, and can be up to the total number, but at least one of them. Okay, so that's why the probability is high, because at least one of them. It does not guarantee that I have 2, guarantee I have 3. It just tell me that I need to have the minimum of 1 person. Okay, so if you have this pin structure, you should change it. Just kidding. But in a sense, the question here, question in terms of the number. Question in terms of how I can or what do I need to extract from the problem. Any question with this particular problem? And if you did the homework, you probably saw this thing here already. And if you're able to do it on the homework, it's the same idea. So any question with this particular item? There's 2 items here. Well, if you don't have question, let's take a look at 4.4. So this is the last item in 4.3, and we finished 4.3 last time. We did the review, and now let's take a look at the last item in 4.4. And the last item in 4.4, we are deal with a fundamental counting principle, or in this book, the fundamental principle of counting. So to be in short, a fundamental counting principle or fundamental principle of counting is basically tell you that if we know the total of one group, and if we know the total of another group, and all we need to do is take the 2 total and multiply them to know how many different ways that we can mix and match 2 items. So for instance, if I ask you, if you go to McDonald's and this McDonald's offer you 8 different burger and 5 different kind of drink, how many ways can you order 1 burger and 1 drink? So if we know the total burger is 8 and the total drink is 5, all we need to do is take the 8 times the 5 to give us the total of 40 different ways that you can order your 2-item meal, right? You can order a Big Mac with a Coke, a Big Mac with a Sprite, a Big Mac with a root beer, a Big Mac with a high C, or a Big Mac with a iced tea, right? So that is 5 different individual order already. Or you can buy the chicken sandwich with a Coke, with a Sprite, right? So as you can see, that's all that you need to do is find the total of the group and take the 2 total and multiply them. Okay, and that's what the fundamental principle of counting or fundamental counting principle tell you to do. And the other thing is the fundamental counting principle does not restrict just to 2 items. It can be as many items as you need it. It means you can order a burger, a drink, and 3 different kind of French fry size, right? You can order a large, a medium, or a small. So as you can see, we have 8 burger, 5 drink, and then 3 different size of French fries, meaning 120 different ways, right? Because the 8 times the 5 is the 40, 40 times 3, you have 120 different ways to order your 3-course meal. And if you say, oh, they have dessert, they have a ice cream, chocolate, or vanilla, which is 2 more options, then again, you take the 8 times the 5 times the 3 times the 2, which is will give you 240 different ways to order that 3 items. And again, whatever else they offer, you can mix and match basically how many ever criteria they have, you multiply their total, okay? So if you take a look at example one, they tell you that the license plates in Louisiana for a compact call contain 3 letters followed by 3 digits. How many different license plates can be made? So basically, we try to program this machine, right? This machine generates the Louisiana license plates. And we want to know if this is the criteria, 3 number followed by 3 letter, or vice versa, 3 letter followed by 3 number, doesn't matter. What is how many license plates can they generate, right? So looking at this item, how many different category, or in this case, how many different slots do we have? Do you agree that we have 3 letters followed by 3 digits, meaning there are 6 different slots that I needed? And if I have 6 different slots, now at each slot or at each category, how many options can I choose? Do you agree that there are 10 single digits? From 0 to 9, there are 10 single digits, and there are 26 letters from A to Z for our English alphabetical letter. From A to Z, we have 26 letters, and from 0 to 9, there are 10 single digits. Why 10? Because 0 is 1 single digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 single digits. Anything after 9 is just the repeated. 10 is the repeated of 1 and 0. 13 is the repeated 1 and 3, right? So looking at this item, a single digit is only from 0 to 9. So question here in terms of, I know that there are 10 single digits and there are 26 letters. So to do this problem, we know that the first 3, they tell us that is followed by, is 3 letters, and is followed by 3 number. Agree? So how many letters do I have? Well, there are 26 times 26 times 26, because there are 26 total letters, and 10 times 10 times 10. So in this case, this machine that I program, this machine can generate 17,576,000 different license plates, okay? And the idea is, all you do is you find the total of each group, or in this case, each slot, and multiply them together. And that's what fundamental counting principle tell you to do. Question with this small license plate problem. The other thing that you might see, or the other thing that you might have, is they might trick you a little bit, and they say, what happened if they don't, repetition does not allow, or you cannot repeated letter is prohibited, right? Meaning basically, if you use the letter H at the first letter, then you cannot use the letter H as the second letter, right? Your license plate cannot be HHH222, right? So basically, they tell you what happened if we cannot repeat our number and we cannot repeat our letter. Well, if that's the case, do you agree that my first number or the first letter, I still have 26 outcome? I still have 26 options from A to Z. It's just like whatever I use in A, I now have 1 less. I only have 25 letters, except not 26, because I used the H already. And if I use the I in the second letter, do you agree that my third option, I only have 24, because my H and my I can no longer be used, because I cannot repeat that item, right? So if they tell you that you cannot repeat your number or your letter, it's just basically you deduct after you use it. Same idea, right? For the number, we have 10 in the beginning, we use 1, now we have 1 less. And again, we use 1, we have 1 less, which all we do is we take 26 times 25 24 times 10 times 9 times 8. And if you time that, you will see that that number is very small compared to the 17 million. Okay, so that's the only thing different is if they may tell you that you cannot repeat your letter and you cannot repeat your number, and that's why you have to go one less, one less, one less. So question here in terms of this particular example one, this license plate problem. And if you don't have question, let's take a look at the last three definitions we have: the permutation, the combination, and the factorial. So let's take a look at the factorial first. Factorial, as you can see, is basically the explanation mark, which is n factorial tell you that is take that number n, whatever that number is, multiply to one less, multiply to one less, multiply to one less, multiply until you get down to 1. You cannot get down to 0 because if you multiply by 0, your answer will be 0. So this is what n factorial tell you to do, is start from n, multiply to one less, multiply to one less, multiply until you get to 1. And the definition, one thing is the 0 factorial is equal to 1. Okay, the 0 factorial is not equal to 0, it's equal to 1. So the next item we have is permutation. And the most important thing about permutation, ladies and gentlemen, is whatever you try to choose, the order matter. So in terms of permutation is basically ask you in how many ways can you arrange something where the order matter. That's it. The factorial is basically how many ways you can arrange the item, the factorial. And now we want to know specifically if we want to arrange the item where the order have an impact, where the ranking is in 4, where there's specific item that we need to put in, then that permutation, and that is what we have is the NPR is equal to n factorial divided by n minus r factorial. And the obstacle and the challenge for you guys in this particular chapter or section 4.4 is how can you determine when are you using the permutation versus when are you using the combination. Okay, so the combination is very similar to the permutation, which is the NCR instead of NPR. The NCR in the sense that we are choosing how many items are out of the total n item, where the order does not matter. It doesn't matter which one comes first, as long as you choose them, they come out. So that is the difference between the permutation versus the combination. And for you guys, the challenge for you guys is when you read the problem, how can you determine is it the NCR that we're using or the NPR? Because looking at this item or looking at this thing here, the calculator can help you in the sense of calculating this NPR and NCR. You don't need to remember your formula because the calculator can help you out very much. So let's take a look at this item here. So if you have your TI-83 or if you have your TI-84 that I have right now, you will see that under the alpha, you have the word second, the word alpha, and under the alpha, you have the math button. If you click on the math button, if you click on the math operation, and then you scroll over to the PRB, which is stand for probability. If you go to PRB, everybody see that option number 2 is NPR, option number 3 is NCR, and option number 4 is the factorial. Meaning your calculator have the built-in formula already. You don't need to, that's why I kind of glance through the formula, because you have your calculator with you. Your calculator can calculate this item for you faster. The only problem is, ladies and gentlemen, you have to know how to use it, right? So let's take a look at this particular problem. For instance, if I ask you to evaluate 21 factorial, 17P9 and 17P C9. So how do we operate, or how do we doing or using our formula? So if you have it's just like it show, all you need to do is type 21 math, and then you go over to P or B and choose option number 4, because the option number 4 tell you to take the factorial, which is 21 factorial will give you this item here, 5.10909 4217 e to the 19. E to the 19 basically tell you take this decimal and move 19 slot to the right, and that's the e to the 19, positive 19. And it's a humongous number. It's basically we have 2, 4, 6, 8, 9. We have 9 right here. We have to go 10 more digit, which is beyond zillion, right? Trillion is too small. It's very humongous number. Okay. So the other one, if you look at this, let me clear. How do we type in the 17P9? Well, to type the 17P9, you need to type the 17 first, and then you choose the NPR, because that is what the P stand for, permutation. So we need to type in 17 NPR and then 9. So whatever number first, you need to write first. The NPR, which accesses from math, go to PRB. And then you just need to press enter. Once you have enter, this will give you your answer. If you look at this thing here, this is 100,000 million, so 8 billion, right? 8,821,612,800 different ways that you can choose 9 items from a group of 17. The question 17P9 is basically tell you that if you have 17 items, and you need to choose 9 of them, where the order matter, meaning the first item comes first, that is important to you. They are ranking. Then there are, again, 17 choosing 9, where the order matter will give you 8,221,612,800. And similarly, to type in the 7, if you type in 7C NCR, option number 3 and 9, as you saw on your screen, this item here are very similar and is identical. The only thing different is instead of the P is a C, and that make a big difference, ladies and gentlemen. The C is always smaller than the P. When you try to do something that does not have an order, the C will always have a less option than the P. And if you look at this thing here, humongously less, right? The P, the NPR, you have 8 billion plus. The NCR, you have only 24,310, right? So look at this thing here. Question on how to navigate your calculator, how to use your calculator to find the permutation and the combination or the factorial. All right, if you don't have question, this is what we have. Let's take a look at how do we, or what obstacle do you run into. So this is the first obstacle that you will run into, which give you all wording. And like I mentioned to you guys earlier, the math in this class is doable. The trouble or the problem is, how can you take this word and how can you take all this English and convert to the math that you know, right? So let's dissect, let's analyze this problem here. Playing the horse. So in the horse racing, one can make a trifecta bet by specifying specifying which horse will come first, which horse will come in second, and which horse will come in third in the correct order. So as you can see, the trifecta, you have to specify the correct, the exact order of first horse, second horse, and third horse. And as you see, the trifecta, and again, probably this is the new terminology that you see, and for me too, right? I took this problem from the book, and from this problem, the word trifecta, I know that they tell me that I need to specifically specify which order the horse come home, right? The first horse, the second horse, the third horse, where the order matter, right? We need to be exact order. And now the other one is one can make a box trifecta. So again, new terminology, but what is the box trifecta? The box trifecta, you can choose any 3 horses that come first, second, and third in any order that does not have a specific item, right? Meaning again, you can choose any 3 horses as long as those 3 horses come first, second, and third. Doesn't matter which one is, doesn't have to be exactly first, second, and third, as long as the 3 horses that you choose come back first, second, third, then that will be a box trifecta, right? So question here in terms of trifecta versus box trifecta. So once we have that information, let's take a look at what they asked me or asked us to do. In a 10 horse field, so we know that this race have a 10 horse. How many different ways can one make a trifecta bet? So if you go to the horse racing and you look at the horse and they ask you if there is a 10 horse in this race, how many different trifecta can you bet, right? Let's say you go in there and you say, I want to bet $1 on a trifecta. How many different bets do you have to make? Well, to make this item here, to know how many ways I can make this trifecta, I need to know first, the trifecta, the order matter. They have to have a specific order, specific first, second, and third. So we know the order matter. And now in this item, how many horses do we have in a race? Do you agree that there are 10 horses? In a 10 horse race, there are 10 horses. And how many are we choosing? We need to choose 3 of them. Why 3? Because it's the first place, second place, and third place. And remember the trifecta, the order matter. And because the order matter, you need to have 10p3. We have 10 horses and we need to choose 3 of them. Everybody see where my 10 come from, where my 3 come from, and why am I using the permutation, the NPR, not the NCR? And if you have that, do you see that if you type in your calculator 10 NPR 3, you will have 720. Meaning if you go in to the racing round and you want to bet all trifecta, if there's a 10 horse and you want to bet all trifecta and $1 a piece, you will need $720 to make this trifecta bet that cover all field. It cover every single way that the horse can come back. You are guaranteed to win, ladies and gentlemen. If they have a 10 horse and you have $720 and you want to bet all trifecta, you guarantee that one of the ticket that you have will be a winner. Okay. And what happened? What is the difference between number 1 versus number 2? Well, number 2, because of the box trifecta, the order doesn't matter. And if the order does not matter, we're using the combination, which is 10C3, and 10C3 will give you 120. So 120 different ways that you can do the box trifecta. And like I mentioned, if you want to go in there and you want to guarantee to have a winning ticket, then you go in and do the box trifecta $1 a piece, you only need $120 to have every single box trifecta in a 10-horse race. And that's why, you know, if you took me from 120, that's where the art come in, right? If you try to say that, oh, you want to be a winner, and that's where the art come in, is different combination of horse. They have different art, and you know, a same ticket might not win as many prize and much a big prize as other ticket if the order, or not the order, if the horse have a better chance of winning, right? So the art is different from probability, or in this case, it's different from the permutation versus combination. Question with this particular problem? Well, if you don't have a question, let's take a look at this item here. Oh, did I skip? No. So this item that we have, let's say that they give you this particular question in an ice cream. A Sun ice cream parlor offer 15 flavor of ice cream. You want an ice cream cone with 4 different scoop of ice cream, right? All different flavor. And now part A, they ask you, in how many ways can you choose a cone if the order of the flavor does not matter? And again, hopefully you guys see, oh, the order does not matter, meaning I'm using my combination. The order doesn't matter, I'm using combination. And if I'm using the combination, I need to know how many total item is there. And from the group of that total item, how many am I choosing, right? So do you agree that there are 15 flavor altogether in this ice cream parlor? And then from this 15 group of flavor, I need to choose 4 of them. And now I have 15C4. Why 15C4? Because the order does not matter. And if you see this item, and I told you that your calculator can help you and a lot, right? Your calculator have a given formula. You just type in 15 NCR4. Press enter, they will give you 1356, 1,356 different ways you can order this 4 scoop of ice cream, where the 4 different scoop, the order doesn't matter. And what is the difference between 2 versus 1? Well, 2, you still order the 4 flavor, but now you are picky and you want a specific item on top, specific item on the middle, and the specific item in the bottom. So as you can see, this thing here, because you want some specific way, because there are some ordering, some scheduling, or some specific item, then this item will be your permutation problem, because it's involved with order. So no order, the order does not matter. Combination, if the orders matter, permutation. And once you have the permutation, the math, the work is not that difficult. Hopefully you guys see how to type in your calculator. So question on how to type in your calculator, or question on how I have this answer here. Any questions so far with this item? Well, let's take a look at one more item and then I will let you guys go. So if you look at this particular item and this previous item here, you will see that they are very somewhat identical. The only thing different is, the story behind it, and they have some specific order that they want it to be, or they ask you for probability. So looking at this thing here, let's dissect, let's read what information they throw at us. The student counselor at a certain school have 15 members. 4 members will form an executive committee consisting of a president, vice president, secretary, and treasurer. So why do I say this problem is the same as this particular problem here? Because this problem, we still have, instead of the member, we have 15 flavor. Instead of choosing 4 officer, over here we're choosing 4 ice cream scoop, right? So in the nature of the item, we still have 15 choosing 4. So let's take a look at number 1. They ask you, in how many ways can this 4 position be filled? So again, do they tell us the order of this item here? How many ways can 4 of this position be filled? Well, they give us a specific title. Because they give us specific title, ladies and gentlemen, is a permutation. You would say, wait, they did not tell you first, second, third. Well, president is more important than the vice president, and the vice president is more important than the secretary, and secretary is more important than the treasurer, right? In the sense that they give you specific name, you have to use permutation. Okay, so you say, well, that is not the order because it's the specific name, or in terms because there's a ranking involved. Because it's a ranking involved, is a permutation. And if we have permutation, we know we have 15 member and we need to choose 4 of them. 15P4. And if you choose 15P4, it's the same answer as before, 32,760. And 2, in how many ways can 4 people be selected for the executive committee if that does not matter who get which position? Meaning, in general, I just want to have 4 people in this item. I figure out who is important later, but now I just need 4 people to fill the position. Do you agree that because the order does not matter, we have a combination? And the combination is the same as the previous one, which is 1,365. So look at this thing here. The information is different, but the math is the same, right? We have 15 choosing 3, 15 choosing 3, just the same as the previous ice cream problem. Now, 3, 4 of the people of the city councilor are Sam, Justin, Brittany, and Rashawn. What is the probability? As you can see, they ask you for probability. So in order for you to find a probability, reminder, we need to know the total. And from the total, we need to know how many or what are we looking for. So what is the probability if Sam is a president, Brittany is a vice president, Justin is a secretary, and Rashawn is a treasurer? So how would we go about to find this probability? Well, first of all, do you agree that this is a simple probability? It's basically, well, how many ways can it be that Sam come as president, Brittany come as vice, Justin come as secretary, and Rashawn come as treasurer? Do you agree that there's only one way? There's only one way that it has to be this specific. It has to be Sam president. If the Sam is vice president, it's not in this one way, right? The one and only way that I want is I want Sam to be president, Brittany to be vice, Justin to be secretary, and Rashawn to be a treasurer. If any of this position does not fill by those individual, then I cannot use it. Meaning there's only one way that this 4 individual fall under this 4 category or title, office. So how many ways do we select the total? How many ways can we select 4 people to fill in this position? Do you agree that there is one way that we choose, which is Sam as president, Brittany as vice, Justin as secretary, and Rashawn as treasurer, out of the total 32,760? And if you look at this item, this is very unusual, right? It's very small, it's very unusual. But what is the difference between number 3 versus any other problem? The biggest difference is they ask you for probability. And to find the probability, you need to know the total. And from the total, how many items are we looking for? And for number 4, they ask you, what's the probability of Sam, Justin, Brittany, and Rashawn are all the 4 committee members? So does the order matter? Well, no, right? Because they don't give a specific rank and specific order. All they want is they want these 4 people to be in the community committee. And to find this item here, how many ways can we select these 4 people? Well, there's only one way, right? There's only one way that this 4, right? If there's a James in here, then that's not the one way that Sam, Justin, and Brittany. But because the order does not matter, because they just want to generalize, then all you need to do is take 1 over the total of the combination, which is 1, 3, 6, 5. And when you divide this thing here, you have 0.732 times 10 to the negative 4. And I purposely give you this to make sure that you guys know that the negative exponent tell you to move it to the left, right? This number, -5, tell you take this number, move it 1, 2, 3, 4, 5, right? And that's where I have 0.003053, okay? And again, first of all, question with any of this thing here on the screen here, question with 1 through 4. Any question in general? Well, ladies and gentlemen, I still have a 2 more problems left, but let's do that on Thursday. Let's stop here for today. If you have questions and you did not able to ask, do